Right, so in this section, we're looking at shifts or translations. And so we've already looked at a couple of problems where I gave you the function and you had to describe the shift that was occurring. And then a few problems where I described the shift in words, and then you give me the function. Here I'm giving you a graph of a basic function that's been shifted, and I'm asking you to find that function. Okay, so basically we go through three steps. We identify the basic graph, we describe the shift that occurs, and then from that we should be able to write the function. Okay, so in the first one, again, you should be able to identify fairly quickly which of the 9 famous functions that we're looking at, and this is the squaring function. So I'll just write y equal to x squared. That's part A. Identify the basic graph. Okay. Now we have to describe the shift. Well, we know that the squaring function started with the vertex here at the origin. Okay. That vertex has clearly moved to the right. Okay. The numbers are a little bit too small to read here, but you could look on your own sheet. And it moves 3 places to the right. Okay. So this is a shift right 3 units. Okay. And then finally, we should know how to write that then. Remember, when it's a shift left or right, it has to happen before we square. And when it goes to the right, you're subtracting. So that would be y equal to x minus 3 quantity squared. Okay. The next one, again, your first step is to just identify the function. You should know that v-shaped function is the absolute value function. So that's the basic graph. Again, it's clearly moved. And here again, we're just watching where the vertex goes. The vertex was here. It obviously moved left and then down. Okay, so it moved left 2 units. And then down 1 unit. And again, we should know how to write this function. 2 shifts, so one will happen before you do the absolute value, and then the down 1. Remember, I'm actually going to start with this one. Down 1 unit, remember, it happens afterwards, so you just go down 1. Left, remember, this was the right when you subtract 3, so if I want to go left 2, I have to take x plus 2. Okay. All right, a couple more. Again, number 3, you're given a basic function shifted. You should again recognize that as the cube root function. Okay. Again, where does it move? Well, this point, I wouldn't call it a vertex, but it normally would be at the origin, and it just moved up 1 unit. Okay, so that's my shift, is just up 1 unit. Well, again, that means I'm going to take my cube root function. I don't do anything before it, but after it, I go up 1, so plus 1. Okay. And then finally for number 4, again, we should recognize this right away as the square root function. Okay. We're used to the square root function starting here at 0, 0, so clearly it went to the right 2 and then down 3 units to start there. So again, that's a shift right 2. And down 3. So again, for our function, when we write it, we have to do something inside the square root, and then the down 3 comes outside the root. Okay. Again, right means you're going to have to subtract. So that's x minus 2. Okay. All right, and then finally, the last kind we have is I give you a graph. It's not one of the 9 famous functions. Sometimes we just look at a graph that I give you, and I'm asking you to perform a few shifts here, okay, and regraph it. Now, I'm not going to do the graph, but I will make a table. Once you have the table, the graph should be immediate, okay? And in general, that's how I would do it anyway. So if I have this graph, instead of worrying about where the graph moves, I just take these important points, or the ones I can identify, -4, 0, -2, 2, 0, 2, 2, 1, 4, 0, and this last one here at 6, -1. And I just sort of look now at the table and say, where do these points move? Regraph them, and I would have my new graph. Okay. So again, clearly for the first one, I have my original function. I'm doing this. It's inside, so that has to be a shift left or right. Okay. But since it's in, it's a -3, that would be a shift right 3 units. So again, when you look at this new table, you have to think about what would change from the original table. When you go right 3, that's going to change the x's. Y's move up and down, but in this case there's no vertical shift. So all these numbers will stay the same. These all move right 3. So if you move right 3 from -4, you wind up at -1. The output would still be 0. When -2, the x coordinate moves right 3 units, it winds up at 1. But again, the output would still be 2. Move the 0 right 3 units, that's at 3. Again, the output is still 2. This one, you shift to right 3, the 2 moves over to 5. Output is still 1. 4 moves over to 7, and 6 moves over to 9. So you would just plot these points, and then you would connect, in this case, since it's connected with straight lines, connect these with straight line segments, and you'd have your new graph. Okay. Clearly in number 2, there's 2 things going on here. We have 2 shifts. So we have this inside shift, which again, inside always means left or right. When it's a +1, that's going to go left. So shift left 1 unit. The outside here is +2, so we go up 2. Okay. So left 1 moves the x coordinates left or decreases it by 1. Up 2 will change all your y coordinates by going up 2. Okay. So again, we just make our new graph, or a new table, sorry. So here we're graphing x +1 +2. So again, all these have to go left 1 unit, so this will go back to -5 and up 2, so the 0 goes to 2. Left 1, so that goes back to -3. Okay. Up 2, so that becomes 4. Left 1, up 2. Left 1, up 2. Left 1, up 2. Left 1, up 2. Okay. So -5, 2, and so on becomes 6 new points here that you can graph to get your new graph. Okay. And then finally, this is just a shift down. Nothing happens inside, so there's no left or right. It's just shift down 2 units. So from our original, make sure you're always going back to the original here. When you go down 2, only the y should change. So my x's would still be the same here, but all the y's go down 2. So 0 goes down to -2, 2 goes down to 0, 1 goes down to -1, 0 goes down to -2, and -1 goes down to -3.